Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a very nice problem with complex numbers. The solution, warning, the solution is going to be super complex, so are you ready for some challenge? Alright, great. So we have x plus yi equals a plus bi to the power c plus di. A, b, c, d, x, y are all real numbers. A, B, C, D are given numbers. In other words, A plus BI and C plus DI are given complex numbers. And our goal is to solve for X and Y. Where does this problem come from? So I made a video a few days ago. I think it was 3 days ago since I got the screenshot today on a very interesting exponential formula where we kind of solve for a Z such that when you raise it to the power A plus BI, it gives you C plus DI. Again, in this case, A plus BI and C plus DI are known numbers or given numbers. For example, A plus BI can be something like 1 plus I, and C plus DI can be something like 2 plus I. And your goal is to solve for Z that satisfies this equation. And I came up with a general formula which you can apply to many different situations, okay? So, after I made that video, there was a beautiful comment by Rule of the Hyperbolic. He wants me to, or she, I guess I made an assumption here, Rule of the Hyperbolic wants me to come up with a formula for a plus bi to the power c plus di, which is x plus yi. So in this case, we're going to be solving for x and y. Thank you for the idea. I love this suggestion. That's why I wanted to make a video right away, as soon as I can. So you ask, I deliver, obviously, as much as I can. Great. So we have an interesting scenario. What are we going to do? So we're going to find a complex number x plus yi, which is the result of a plus bi being raised to c plus di. A complex number to a complex power. How complex can that get, right? So this is complex exponentiation. And we're going to be using some basic rules of complex exponentiation to be able to solve this problem. One of the things that we definitely need for this problem is using the natural log, right? So the rule says if you have something like z to the w, and z and w are complex numbers, obviously, which includes real numbers, then you can write it as e to the power w ln z. And notice that if z is 1, ln z is 0, and you get 1 to the power w equals e to the power 0, which is 1. So any power of 1 is 1. Is it always true? What happens if you raise it to the power 1/2? 1 to the power 1/2, the square roots of 1. Okay, that's kind of like a gray area. I made a video about that. You can go ahead and check that out. I'll try to link it here. Okay, so let's go ahead and apply this to our situation. I'm going to focus on this first, ignore x plus yi, and I'll introduce x plus yi towards the end because I don't want to keep writing it. I'm kind of lazy. You know, what can you do about it, right? I mean, they say a good mathematician is a lazy one. By the way, I don't consider myself a mathematician, but, you know, anyways, I don't know. I don't know what I was trying to get at. So let's focus on this, and here's how we're going to do it. First, by using the formula a plus bi to the power c plus di can be written as e to the power c plus di multiplied by ln a plus bi. By the way, I gotta warn you, this is going to be multi-valued because the log of a complex number doesn't have a single value. A complex number has a single value, but if you express it in the polar form, then you can express it in so many different ways, which turns out to be the same complex number. Same thing for the log of a complex number because it's just another complex number, but you can express it in different ways. Anyways, so here's what I'm going to do. I want to set a plus bi to r e to the I theta, where r is the absolute value of a plus bi, or the modulus. I just used abs for absolute value. Those are your abs. And then theta is the argument, and I'm going to use arg for that. Make sense? That's the angle. Okay, great. So r needs to be greater than or equal to 0. R and theta are real numbers. A and b are real numbers. Make sense? So let's go ahead and evaluate it and plug it in. R is going to be the square root of a squared plus b squared. Just Pythagorean theorem. And tangent theta is going to be b over a. If you think about it, in the argand plane, you plug, like plot a plus bi, and then tangent theta is going to be b over a. And it doesn't have to be in the first quadrant. It's always b over a, because in the second quadrant, for example, tangent is going to be negative, so on and so forth. Make sense? So now, when you ln a plus bi, you're basically lning, is that a word? R e to the I theta, which gives you ln r plus I theta. Here, ln r is just a real value to ln because r is greater than or equal to 0, and you don't want it to be 0 either, so let's keep it positive. Okay? Let's plug it in now. ln a plus bi is going to be then ln square root of a squared plus b squared plus I times theta. Uh-oh. I don't have theta, I have tangent theta. What can I do? Arctan, right? Arctan comes to the rescue. So from here, theta is arctan b over a. Something that we're going to use, something we used earlier for the other formula that I just showed you. Now, I want you to consider the variations based on the quadrant, so this is not a single value. Make sense? Sometimes you add pi, sometimes you subtract pi from it, or subtract it from pi, something like that. I guess you subtract from pi, something like that. Anyways, we will figure it out. So this is my ln a plus bi. Let's go ahead and plug it in. Oops, I forgot to include the theta. Yes, theta is now arctan b over a. So I do have an expression for ln a plus bi. Let's go ahead and plug it into our equation. Where's the equation? Right here. So this is my a plus bi to the power c plus di. So a plus bi to the power c plus di is equal to e to the power c plus di, which is a complex number, multiplied by the ln of a plus bi, which is another complex number, by the way. I'm going to just copy that from above, and this is what you're going to get. And I should probably keep b over a in parentheses all the time, right? Cool, cool. Is that the answer? Almost, because we're supposed to express it as x plus yi. By the way, I realized in my other video, I didn't express it and somebody brought it up, I think. Sorry about that, I forgot because that was already too exciting and a long video, didn't want to make it longer. Anyways, so this is the answer, and notice that this is equal to x plus yi. So what I need from here is the real part and the imaginary part. That's an exponential. I kind of have to split it up into two pieces, but before that, I need to distribute. Let's go ahead and distribute this. And when you distribute, can I tell you what you're going to get at the end? Let me go ahead and show you. When you distribute, x plus yi is going to be e to the power, are you ready for this? Okay, c over 2 times ln a squared plus b squared. By the way, 1/2 comes from the square root, because ln 1 to the power 1/2 is just going to bring a negative, bring 1/2. And then you got to be careful here. It's d times arctangent. Hopefully you understand that. Otherwise, it's going to read like dark. It's kind of like we're on the dark side already, but you get the idea. This is d times arctangent. Okay, you get the idea? Hopefully. Plus I, and the imaginary part is equally bad. C times arctangent b over a. I put the dot there. Plus d over 2 multiplied by ln a squared plus b squared. Great. Such a mess, right? Now this is e to the power something. I still have to split it up. So now what you're going to do is, because the exponents are added, in other words, this is what I'm trying to do. Let me just show you real quick. Whenever you have e to the power m plus ni, you can write it as e to the m times e to the ni. This becomes the what? Modulus, and here this becomes your theta, because remember, r e to the I theta, same format. So whatever multiplies I is going to be your theta for the new number. Don't get me wrong. Maybe I'll just call it alpha. And I'm going to call this one not R, but maybe R sub 1. Okay, how about that? And R sub 1 is just the modulus for x plus yi, right? In other words, the square root of x squared plus y squared. Okay, here's the story. If you go ahead and split it up, you're going to get something like this. E to the power c over 2 ln a squared plus b squared minus d times arctangent b over a. And then this will be multiplied by e to the power I times this. But e to the I theta can be written as cosine theta plus I sine theta. And if you do that, you're going to get something that starts off like this. It's huge, so I'm maybe just going to show you part of it because I have written up nicely. C cosine of C times arctangent B over A plus D over 2 ln, not the square root, but ln A squared plus B squared. And then when you separate this, like multiply these two, that's going to give you x, because it's x plus y. I remember. Don't you just love it? Let me show you. Okay, this is what it looks like. Ta-da! All right, great. So basically, after solving that equation, remember we were trying to solve for this. X plus yi equals a plus bi to the power c plus di. X and y are going to be these values. And notice the similarities. One of them has a cosine, the other one has a sine. If you divide y by x, you get the tangent of the angle alpha, which is this whole thing. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.